Nitric acid or phosphoric acid? Which one is stronger and why? This is today's lesson. So let's begin. Let's see oxidation number of the central atoms of nitric acid and phosphoric acid. This is nitric acid and this is phosphoric acid. In case of nitric acid, oxidation number of nitrogen is here, this is -2, total -6, this is +1. For nitrogen, oxidation number is +5. And in case of phosphoric acid, here -2, total -8. This is +1, total +3. Because here there are 3 hydrogen atoms. That is why total +3. So oxidation number of phosphorus is here +5. That means in nitrogen of nitric acid this is +5, and in phosphorus of phosphoric acid this is +5 as well. We know that the more the oxidation number, the stronger the acid. But here oxidation number same. Then which one will be stronger? Let's see the positions of these elements in the periodic table. In the periodic table, nitrogen, phosphorus belong to column 15. Let's see. Column 15, nitrogen, phosphorus, arsenic, antimony, bismuth, and finally moscovium. We know that from top to bottom atomic sizes increase in this way. Suppose this is atom of nitrogen, this is phosphorus, this is arsenic, like this. That is, from top to bottom atomic sizes increase. Now let's go to the acids, that is nitric acid and phosphoric acid. Here nitrogen is smaller in size with +5 charge, and in case of phosphoric acid this is bigger in size with +5 charge. So in case of nitrogen, charge density is higher than that of phosphorus because this is smaller in size than phosphorus. Charge density is defined as the amount of charge or the quantity of charge per unit area of a surface. So in this case, charge density is very high compared to phosphorus. And we know electronegativity increases with the smaller size of atoms. That means the smaller the atoms, electronegativity is higher. So in case of nitrogen, electronegativity is 3.1 and electronegativity of phosphorus is 2.1. So in case of nitric acid, nitrogen is bonded to oxygen. This oxygen is bonded to hydrogen. In case of phosphoric acid as well, phosphorus is bonded to oxygen. This oxygen is bonded to hydrogen in case of phosphoric acid. Here, on one hand, charge density of nitrogen is higher than phosphorus. On the other hand, electronegativity of nitrogen is more than phosphorus. As a result, these electrons move towards nitrogen, and subsequently this hydrogen is freed as proton easily and comfortably. But in case of phosphoric acid, its charge density is lower and its electronegativity is lower as well. That is why this movement of electrons from hydrogen oxygen bond towards phosphorus is not as strong as in nitric acid. That is why from this compound this hydrogen is freed as proton, but not comfortably, not easily. This is hard to produce proton for the phosphoric acid. That is why nitric acid is a stronger acid than phosphoric acid, because nitric acid produces proton easily and comfortably, but phosphoric acid produces proton laboriously, or it produces proton hard. That is why nitric acid is a stronger acid than phosphoric acid. Let's see some more examples. Now, nitrous acid and phosphorus acid. Let's write the acids. Nitrous acid and phosphorus acid. In nitrous acid, oxidation number of nitrogen is +3. Here, oxidation number of phosphorus is +3. Same oxidation number, then which one is stronger and why? Like previous set, here nitrogen, phosphorus, arsenic, antimony, bismuth. That means nitrogen is smaller, phosphorus is bigger. So here nitrogen is smaller with 3+ charge and phosphorus is bigger with same charge. Here charge density is very high compared to phosphorus, and electronegativity is higher as well compared to phosphorus. So from nitric acid, this hydrogen is freed as proton easily, and from phosphorus acid, this hydrogen is freed as proton but not easily. That is why nitrous acid is a stronger acid than phosphorus acid. Now, sulfurous acid and selenious acid. Let's write the acids. H2SO3 and H2SeO3. In sulfurous acid, oxidation number of sulfur is +4. Here oxidation number of selenium is +4. Now let's see positions of these elements in the periodic table. Oxygen, sulfur, selenium, tellurium, polonium, livermorium. That is, oxygen is smaller in size than selenium. That is why, though oxygen and selenium are carrying same charge, but their charge densities are different. In case of sulfur, its charge density is high compared to selenium. That is why sulfurous acid produces proton easily than selenious acid. For this reason, sulfurous acid is stronger acid than selenious acid. Now let's see about perhalic acids. Now, perhalic acids. First of all, let's write formulae of perhalic acids. HClO4, perchloric acid. HBrO4, perbromic acid. And HIO4, periodic acid. In case of perchloric acid, oxidation number of chlorine is +7. Here bromine +7, and for iodine +7 too. Now let's see which one is stronger. Though chlorine, bromine and iodine are carrying same charge. Let's see positions of the halogens in the periodic table. Halogens belong to column 17: fluorine, chlorine, bromine, iodine, astatine and tennessine. So from the positions of halogens in the periodic table, we can say that chlorine is smaller in size, bromine is a bit bigger, and iodine is more bigger. So in case of perchloric acid, charge density of chlorine is very high, and here this is comparatively lower, and in case of iodine this is lowest. That is, in perchloric acid charge density is highest, and in periodic acid charge density of iodine is lowest. Again, we know electronegativity of chlorine is 3.0, for bromine 2.8, and for iodine this is 2.5. On one hand, charge density is very high for chlorine in perchloric acid. On the other hand, electronegativity of chlorine is higher than bromine and iodine. Because of this higher charge density and higher electronegativity, perchloric acid produces proton easily, then perbromic acid produces proton not easily like perchloric acid, and periodic acid produces proton but not comfortably. It produces proton laboriously. From the consideration of charge density and electronegativity, perchloric acid is stronger than perbromic acid, and finally periodic acid. This is about strength of perhalic acids. No more today. Thank you very much.